Hello everyone, and today I'm going to provide a summary of this book, as you can see on the screen, that is designing data intensive applications. What I have done is that I have read the first chapter and I'm halfway through. So, I've written this summary through pages, and what I've learned is that in this book we are mainly talking about how we are designing these data intensive applications. And see, as you can see on the screen now, that is the page one summary. Okay, so applications of today are more demanding than computational resources. So our focus should be more on handling how we store the data and derive it rather than worrying about computational resources. So the application which we use today, so as they are more data intensive, so we should worry much about designing these application rather than worrying about computational resources. So you can read here that many data intensive applications need to store data, that is why we need a database for that. And some application, as you may know, that they may frequently need some data that is not changing, so that they can achieve that data through cache. So if I write here that there is that we need a database first of all. Okay, and if after that some of the application they need cache for which uh, the data is frequently accessed. Okay, is frequently accessed, and it is the data does not change frequently, right? So it should not change frequently. So this is what is meant by it. Okay, so we also in some cases need to find the data through a particular value by filtering in database, and this can be achieved through indexes in database. So we are requiring index. So we need index because index help us to filter the data out, right? So indexes are required to filter the data out, and handling of data is mainly abstraction. So when we talk to our database, we do not know about its implementation details. So this is in simplicity means by abstraction. So when we do not have to worry about which data structure should be implemented from scratch when thinking about creating indexes. We just tell the database, hey, I need to create an index, and it creates it. So this was the first page summary. Okay, and if we move to the next page, so this page now talks about scalability, reliability, and maintainability when we create these data intensive applications. So there are different tools to store data, and these tools somewhat have a similarity between them, that is storing data. So the main difference lies in how they are accessed and what and for what purpose they are used. So the example given here is that we use Redis to store message queues, but we can also use Kafka for that same purpose, and it guarantees data durability. So these are the tools which are used to perform a very similar type of functions. So there is so now we can see that the blur between these tools is very little, and we often use these tools together for different purposes as our application requirements are changing or very demanding. So we often use these tools together when we create this type of when we create applications in general. And these and what bind these tools together is through the application code that we are using. And now moving to the next page. So we are then combining these tools together through our application code. And we also know that we have to write APIs that interact with these tools, and these are usually hidden from the end users, means that the end users does not know about the particular abstraction layer. And so now the book is asking the main questions. Okay, so how to ensure the end users are getting the correct data if we are using many data storage tools. Okay, so the main problem now arises that suppose we are using, let's say we are using a database first. Okay, database in our application. Now as our application grows, there is some part that needs to be frequently accessed, and we implement a cache. So when we implement that cache, we now have to make sure that the data is consistent in both first the database and the cache. And if the database is if sorry if the data is not like are not same, so it means that the users may be getting the different data. Okay, different at the different times of the request, which may create a problem. So so let's see. So now the second question is how to ensure consistency if parts of the application are degraded. Okay, so there may be an API written where now that and now the business logic, like let's suppose it no longer works or is producing the false output. So we have to ensure consistency in that API. And the next is how to scale to increase our load. Okay, when our users grow in our application, then how we are how we are uh, essentially using our scalability. And now to the next part, that now let's talk about reliability, maintainability, and scalability. So if we talk about reliability, so starting with reliability means that our software should give the correct output in simple terms. Okay, let's suppose our we have our system that is a bank management system. Okay, so inside this system, we need to make sure that whenever the output is whenever the function withdrawn is written, it should actually withdraw and not add. Okay, so this is in simple terms what is meant by reliability. Maintainability means that our system is adapting to the current behavior over time, and also our system adapts to new changes or features that we may add. So this is what is meant by maintainability, that our system means over the future. Okay, over the next course that are whenever we use our system, it means that it should do the same thing that it was doing earlier. Okay, and also that if we also need to add any new features, then our system should adapt to those new features. Okay, and scalability means that our as our data and users grow, how to adapt to the growing use cases. Okay, so this is in simple term means scalability. Now now we are talking about a difference between fault and a failure. Okay, a fault is when a component of a system does not give the correct output. Okay, so if I talk about fault. Okay, so a fault may occur in any particular function. Okay, so this is a simple terms means fault. But a failure, if we talk about failure, a failure happens when a system as a whole stops working. Okay, so this is what is meant by failure. And our aim is generally to make our system fault tolerant, where some amount of fault is tolerable. Okay, so we should design our system in such a way that uh, even if there is some kind of a fault that may happen or some kind of bug, then we should be able to deal with it. Okay, but there are some cases where fault prevention is necessary, like making our data secure. So if we look at web security or different cyber security attacks, So here we do not want attackers to exploit even the smallest fault. Okay, so in this case, in this particular case, fault prevention is necessary, but in other cases a fault tolerant is mainly used. Okay, so there are other approaches to make our system fault tolerant, like error handling or by inducing faults through which we can handle it correctly. What it means is that if we write a proper mechanism to handle these errors, okay, that occurs when we use our system. So it means that we are making it fault tolerant by knowing that which kind of error we are getting. Okay, and also if we try to deliberately make some kind of errors in our system, then it also helps by knowing that when we do this kind of activities, then the fault may happen, and then we can take steps on how to handle it correctly. So I think this was all about it. Okay, so I hope you like the video, and you have to stay tuned for the upcoming videos. Okay, and I will be summarizing more and more chapters regarding this book. So have a nice day.